Assalamualaikum warahmatullahi wabarakatuh. Today, my teammates and I will present the project. So, our project is about the counter design, and we all decide to choose project number 2. Before I go more further, I like to introduce myself and my teammate. So, my name is Cik Wan Syahidan Amrin bin Cik Wan Sopi, and my teammates Muhammad Syamsul Amri bin Yazid and Muhammad Nabil Ifat bin Muhammad Nasibi. Okay, first, our project background. Like shift register and other conventional circuits, there is another important element in digital electronics which we use most. They are counters. Counters are used not only for counting but also measuring frequency and time. Counters are specially designed synchronous sequential circuits in which the state of the counter is equal to the count held in the circuit by the flip-flops. Counters calculate or note down the number that how many times an event occur. Counters are the crucial hardware components and are defined as the digital circuit which is used to count the number of pulses. Counters are well known to us as the timers. Counter circuits are the best example for the flip-flop application. Counters are designed by grouping of flip-flops and applying a single clock signal to them. In simple words, the counters are those which have the group of storage element like the flip-flop to hold the count. Next, decoder is a circuit that generates an output from the binary state of an input signal. It's found in a variety of products including digital watch, calculators, and cell phone. The decoders were used to convert binary into multi-segment data, which was then utilized to drive the display. BCD to 7-segment decoder is the name of the display. BCD digit is converted into 7 signals which are utilized to drive the display segments. Each segment is a tiny light emitting diode LED that illuminates when an electrical signal is applied to it. Next, our problem segment. For this project, we need to design a circuit that increments a digit, which are number 1, 3, 4, 6, 8, 10, 11, 13, and 14 that shown on the 7-segment display device. One each second, an undesired number will return to number 8. So, to get this output, we must design a 4-bit synchronous counter using JK flip-flop, a clock, and a 7-segment display decoder. Next, for our objective, the project is conducted based on several objectives. So for this project, we have 3 objectives. First, to design a 4-bit synchronous counter using JK flip-flop. Second, to design process including the basic equation, truth table, logic expression, logic circuits, and related IC. And lastly, to simulate the design with multi-sim software and display the output to the 7-segment display.
Assalamualaikum. I will be explaining the method and process for this project. This project we will be making a 4-digit synchronous counter that will only show the number 1, 3, 4, 6, 8, 10, 11, 13, and 14. And any other number beside that will be changed to 8. First of all, we will make the truth table, which will show the present and the next state, and also the FF control inputs. In the present state, we will fill it with all 16 digits from 0 to 15, and in the next state, we will change the number from the present state, like 0 to 1, 1 to 2, and 2 to 3, and so on. But in the next step, we will change all the unwanted number, which is 0, 2, 5, 7, 9, 12, and 15 into 8. All of this will be done in binary. And using the JKFF transition table, we will find the J and K for each flip-flop, like you can see here. After that, we will take all the result and put it into the K map. So like this and this, and we will change the x or dot k into 1 to get the maximum boolean. Using the k map, we can get the logic expression down below it, and using this logic expression we can assemble a logic circuit like this. On the left is just the flip-flop with all the inputs it needed and output, and on the right is the one with the full setup like the process supposed to be. And another sample using rather than 7 segment, we will using DCD for convenient purpose to show the display. And as you can see at the timer below, at the first second it show 8, which is 2 since 0 is an unwanted number, and it will change to 8. And on the right, it's on the second it show 1 since we want 1 in our project. So yes, that's all I have.
I will continue with discussion part. In discussion part, I will summarize generally and briefly about project and what were the results and what were the problem and solutions. The aim for this project is to give an overview of 4-bit synchronous counter by using JK flip-flops. So in this project, we have implemented the circuit that the increment digits combined with desired and undesired number that shown on hexadecimal display once each second. The result when stimulate the complete circuit in multi-sim software at the first second, the display shows a digit is 8. This is because 0 is undesired number. The same goes to the other undesired number. It shows a digit 8. Yeah. And then at the second, the hexadecimal display show a digit 1, like the desired increment number. So we can see the output from this project. As shown in Figure 1, the JK flip-flop counter circuit in the 4-bit synchronous counter, the four flip-flops are clocked simultaneously, which means they are connected to the same clock input. Okay, now I will continue with about the problems and solution parts. The first problem is the circuit is compact to design and identify the constituent element in the multi-sim software. And then the precaution is we watch the video and discuss with each other with group members to understand the basic elements of multi-sim software. The next problem is the disorganized of complete circuit. It might be hard to trace if it has any problem when it's running. So we have arranged the wire connector by using a different color to make it more organized. I will give an example in the next slide. The next problem is the second digit on the 7-segment display decoder or the hexadecimal display was not fully functional. What we did is we recognize and troubleshoot on the circuit by check each J and K inputs to ensure all JK inputs is correct. Okay. The conclusion is we must ensure all the inputs of J and K flip-flops is correct. It is very important to get the right connections in design circuits so that the hexadecimal display show the correct reading in our project.